This is a solution video to question 7 of paper 2 of the TMUA 2020 exam. So, in this question, we're given that PQRS is a parallelogram and it's labeled anti-clockwise, and we're asked which of the following conditions, which of these conditions is or are individually sufficient, so which one alone is sufficient for PQRS, for a parallelogram, to actually be a square. So let's go ahead and think about that. So let's think about what conditions we need for our parallelogram to be a square. Well, a square is essentially a parallelogram where all the sides are equal and all the angles are 90 degrees. So the properties of the square we're looking at are right angles at all corners and all edges must have the same length. So we want to show or find a counter. We want to show that say for example, if we want to show that 1 is sufficient, then what we need to show is that 1 implies that all the angles at the corners are right angles and all the edges are equal length. And if we want to show that a condition, say condition 1 is not true, is not sufficient, then we'll need to find an example of a parallelogram that satisfies condition 1, but which is not a square. So let's think about condition 1. Condition 1 is saying the length of PQ is equal to the length of QR, so that adjacent lengths are equal. So if we draw a picture, then our parallelogram is going to look something like this. So this is a parallelogram with all sides being equal. So it's essentially we're saying, okay, condition 2, is satisfied. But that doesn't say anything about condition 1. So in particular, a counterexample to condition 1 would be to have a rhombus, because a rhombus will have all sides to be equal. So condition 1 is satisfied, and it's a parallelogram. But the angle here, the angle at P, for example, doesn't have to be 90 degrees. It could be anything. It could be 120 degrees or something like that. So a particular counterexample would be a rhombus with the angle here being, say, 120 degrees or something. So 1 is not sufficient. So now we look at question 2, at condition 2. This time we're saying the diagonals, so PR and QS, intersect at right angles. Well, if we look at this rhombus, for example, well, we can see that if I draw a line here and a line here, then they're going to intersect at right angles. So we might think that a rhombus is, again, a counterexample to condition 2. So, again, if we look at it, so a rhombus is something that's is very much a parallelogram, and they intersect at right angles here. So this angle here and this angle and this angle and this angle, all right angles. So that means that a rhombus is a counterexample, so 2 is not sufficient. Next, if we look at condition 3 is a condition on the angles now. So we're told that angle PQR, so the angle here, is the same as the angle as QRS here. Now, since these two lines are parallel, that means the sum of this angle and this angle, so the angle at Q and the angle at R, sum to 180 degrees. So if this is true and condition 3 is true, that means that the angle here and the angle here must be 90 degrees. So what condition 3 is saying is that we have PQRS being a parallelogram with 90 degrees at all corners. So of course a square does satisfy this condition, but another quadrilateral or another parallelogram that satisfies this is also a rectangle. So a rectangle is a parallelogram where all the corners have right angles. So a rectangle is a counterexample to condition 3. So that means condition 3 is not sufficient, so none of the conditions are sufficient. So our answer must be H.